Today, we are taking a practical look at how to speed up a slow Windows PC. Diagnose before you optimize. Goal: a slow PC can be caused by CPU saturation, insufficient RAM, a full or failing disk, background updates, startup software, thermal throttling, browser workload, malware, or simply hardware that is too limited for the task. This guide measures first and changes one thing at a time, so you do not install risky optimizer software or disable Windows protections for a temporary benchmark gain. Restart the PC and reproduce the slowdown with only the necessary applications open. Open Task Manager and watch CPU, memory, disk, and GPU during the slow moment. Check free space on the system drive. Review startup apps and disable only items you recognize and do not need at sign-in. Install Windows and manufacturer updates. Check temperatures, fan behavior, and storage health if performance degrades under load. Expected result: you identify the bottleneck category and apply a targeted, reversible change rather than a generic speed boost. A few minutes when the slowdown can be reproduced. Task Manager and Windows settings. A backup if the PC shows disk errors, crashes, or other signs of hardware failure. The exact workload that feels slow: boot, browser, game, file copy, video editing, or general responsiveness. Task Manager is the first useful tool because it separates CPU, memory, disk, network, and GPU pressure. A system at 95% memory behaves differently from one whose CPU is pegged by a rendering job. Likewise, 100% disk activity on a hard drive is not the same problem as a GPU-limited game. Run the following in PowerShell without administrator rights. It lists processes with high working set memory along with CPU time. It is read-only and has no values to replace. The output is a snapshot, so compare it with Task Manager while the slowdown is happening. High memory use is not automatically a bug. A browser, IDE, virtual machine, game, or editor may legitimately use a lot of RAM. The question is whether the system is under pressure and paging heavily. Use Settings, Apps Startup, or Task Manager's Startup Apps page. Disable only programs you recognize and can open manually later. Do not disable security agents, touchpad utilities, storage controller software, or unknown enterprise tools simply because they have a startup impact rating. A nearly full system drive can slow updates and temporary operations. Free space using Windows storage settings. If the PC freezes during file access, reports I/O errors, or the drive disappears intermittently, stop optimization and investigate storage health first. Performance tuning does not repair failing hardware. Windows Update can temporarily use CPU, disk, and network in the background. Let pending updates finish and restart before judging performance. For graphics, chipset, Wi-Fi, and storage problems, prefer Windows Update or the hardware manufacturer's official driver packages. Avoid driver updater utilities that install unverified versions across the system. Laptops and compact PCs may reduce CPU-GPU frequency when cooling is insufficient. A machine that starts fast and becomes slow after several minutes of heavy load is different from one that is slow immediately after boot. Check airflow, dust buildup, fan behavior, and manufacturer thermal diagnostics before changing Windows registry settings. If memory remains near capacity and the system constantly pages to disk, closing unused applications can help immediately. For a permanent solution, reduce workload or add RAM if the device supports it. Disabling the page file is usually not a performance fix and can cause application failures. Let Windows manage virtual memory unless you have a documented specialist requirement. Do not install RAM cleaners that merely force cached memory out. Do not disable Windows Defender, updates, or security services for normal performance tuning. Do not apply large registry tweak packs when you cannot explain each change. Do not delete system files to make benchmarks look better. Measure before and after under the same workload. Record boot time, application launch time, frame rate, render time, or another meaningful metric. A change that lowers one task manager percentage but does not improve the real task is not necessarily useful. Disk is at 100%. Determine whether it is updates, indexing, paging, application I/O, or hardware trouble. On very limited hardware, it can slightly reduce graphical overhead, but it is not a substitute for diagnosing the actual bottleneck. No, heavy legitimate I/O, paging, updates, and indexing can also reach 100%. If a mechanical failing drive is the bottleneck, an SSD or drive replacement may matter more than software tuning. The key principle: optimization without diagnosis often trades stability or security for an improvement you cannot even measure. For more details, read the complete article on the blog.